If you're a painter and you're about to create a new work of art, before you get started, you'll need to make some decisions, like, do you want to buy a canvas or paper to paint on? What kind of paint will you be using? Acrylic, watercolor, oil? What kind of brushes do you want to use? You can use any combination of different canvases, paint, and brushes to make a painting, but your end result will likely end up looking very different depending on the selections you make. While you can use a tiny brush to fill in an entire canvas with one color, that'll be a lot more effort than just using a big brush in the first place. Visualization works in a similar way. There are many different tools that you can use to create your masterpiece, and each will have their pros and their cons. The good news is that you don't have to make your own canvas or brushes. There are many to choose from. Over the years, people have developed tools that take care of a lot of the common problems that come up over and over. Software that deals with 3D data creates a virtual space with its own coordinate system, and it understands things like points and meshes, so you don't have to figure out how to implement these concepts from scratch. Different industries have their own tools to fit their specific visualization needs. Just to name a few of the more well-known tools, Tableau, D3, and Excel are popular for 2D information visualization, a topic that's covered in other courses on Coursera. For 3D scientific visualization, scientists typically use tools like ParaView, Visit, YT, VMD, and others for data analysis. Science communicators who make 3D illustrations or visualizations for TV, films, and museums often use visual effects tools like Houdini, Maya, or Blender. If we want to make a cinematic scientific visualization, we can choose to work with either scientific or cinematic tools, depending on the specific needs of your project or your personal preferences. No single tool understands all possible coordinate systems and data formats. If you're using a visual effects tool like Houdini or Blender, these only natively understand the most universal data formats. All volumes have to be uniform Cartesian grids, but scientific data often comes in all sorts of different types of grids. While it's certainly possible to import scientific data into visual effects software, it's kind of like using the wrong kind of brush for your painting. You can draw a thin line with a thick brush, but that can take some extra effort to do, and there is a better tool for the job. Scientific tools are able to read many complex data formats, and they understand details that may be specific to a domain of science. Molecular visualization tools, for example, may natively understand connections between data points, interpreting them as bonds between atoms, or they may know how molecules connect to form proteins, and have different options for showing these groups of data points. But sometimes, scientific tools may be difficult to understand if you're not a scientist and you're not familiar with the topic or the vocabulary. And unfortunately, many scientific tools are specific to a single field of science. You can't use a molecular visualization tool to visualize a galaxy. If you're visualizing a wide variety of sciences, sometimes working with ocean data, other times with agriculture data, you may not want to have to learn a different tool for each new scientific domain. This is an argument for working with either a more general-purpose scientific tool or a visual effects tool. But such general tools will require customization. If you're working with a visual effects tool, you'll have to create a custom data importer for every different data file format that you're working with. The good news is that you can import your data, whatever it is, into one tool and do all of your visualization work there. You can become an expert in one tool rather than a novice in many. But as you can imagine, getting the tool customized and your data imported can take a long time. And after you load in your data, you'll have to spend time setting up lighting, selecting colors, creating a camera, all that before you can render your first image. On the other hand, scientific tools are often able to get you an image pretty quickly, often with just a few clicks. Scientific tools natively read scientific data formats and use some preset default settings, so you don't have to spend much time on setup, and you won't come up with a black image if you forget to add lights. Though you can get an image pretty quickly out of scientific software, it can be difficult to get a cinematic, photorealistic, or otherwise deliberately designed image. Scientific tools are made to enable scientists to analyze their data, and data doesn't necessarily need to be beautiful in order to be useful. So scientific software focuses on utilitarian tools rather than aesthetic tools. Artistic tools have a visual interface with buttons and sliders to control features like color and camera and lighting, so you can interactively choose exactly where, how, and when you want the colors to change or camera to move. If you want to add a light to your scene, you can intuitively click and drag it to any position that you want, and change the direction, the shadow, the color, intensity, and other values. But with a scientific tool, your lighting options will likely be much more limited. Lighting, camera, color, and artistic or design elements are often difficult to add or change in scientific software. Visual effects software, on the other hand, works with the concept of a scene. You can add objects like lights and cameras and other geometry to your scene, whereas in scientific software, the view is based just around the data set. In visual effects software, you can even add multiple data sets to a single scene. This visualization of the sun was made with visual effects software and combines 5 different data sets, which wouldn't be possible in most scientific software. Here we're looking at a combination of a simulation of the sun's interior, another simulation of the sun's exterior, photographic imagery along the rim, and more. All of these differences boil down to the fact that scientific software is made for scientists and visual effects software is made for artists. As a scientific visualization creator, you fall somewhere in the middle. Scientific tools more easily make you an image that's useful for data analysis, but will be difficult to make appear cinematic. Visual effects tools will easily make production quality imagery, but will be difficult to work with complex scientific data formats. You need to think about the audience for which you're making the visualization in order to make the best choice of software. Fun fact: scientific visualization software and visual effects software have been borrowing techniques from each other for years. Computer graphics were originally started in a scientific lab at the University of Utah, and tools for data exploration eventually found their way to Hollywood for scene design. But then movie makers created techniques like depth of field and motion blur to mimic their physical cameras, which some scientific tools have now also integrated. Ultimately, the tools we have today are thanks to the cooperation of scientists and artists.